Hello, in this video we show how to represent the tabular data as tensors as input in the PyTorch machine learning module. So we know the tabular data is like a spreadsheet and the columns usually can be of different types and the data usually will be read from a CSV file. And the PyTorch tensors on the other hand is homogeneous for each value, each element usually is a number and typically the floating point for the input in deep learning module in PyTorch. And we have to read this file to the NumPy array, then transform to the PyTorch tensor. So we show an example of one quality dataset. So next we go to Python IDE. So we will work with this file. And first we set the working directory and import NumPy and PyTorch module. And we also import the CSV module. Then from this location, we will we will use the function from NumPy load text. Then for this parse, and we set the float point as data type, and we set the delimiter using semicolon and skip first row because this is for the variable name. So you can see this is the NumPy array. Sorry. This is NumPy array, red. And we can also show the first line of this file to take a look at the column labels. Then we show this NumPy array's data shape and column label. So about 4,898 rows and 12 columns. This is the column label for variables. And we will use the quality, for example, for the target value for in the machine learning, and other variables or one of other variables as the input variable. So next step is to use the PyTorch's from NumPy function to transform this, to read this NumPy array, then transform to PyTorch tensor format and save to a new object. So now this object is a tensor and we show the shape and the data type. You can also use the same function as in the NumPy array. So this is the torch size tensor with the same shape from the NumPy and float point as the D type. Then next step is usually to take the target variable out to save to a one individual tensor. This is the target label, and we take another variable into another tensor as the input. So this is the data part. So we exclude the last column. So you can see this data input have 4,898 rows and 11 columns. And this is the target variable, target tensor, with only one dimension with 4,898. And this value is 6677. This is from the quality, has 10 different quality number. So next step is to set this value type as the integer value type. So we use a long function here. So although you can see no difference, but this is a integer value because we want to use one-hot encoding. So one-hot encoding means one value will be transformed as size of columns same as the different values. For example, the quality has 10 values, so we have to set 10 columns for one value. And which number, for example, the number in the original quality is 6, then we will use to set the 7th column as 1, other columns as 0. This is like a dummy variable, so we call this one-hot encoding. And we will first create a tensor with the rows of 4898 and 10 columns. So 10 columns will be filled with 1 or 0, and with the 1 corresponding to the index of the original target value. So we first show this target one-hot. So you can see the rows as same as before, the columns now is 10. Then we will fill 1 for index number for each row. And this operation will use scatter function, scatter with underscore, which means the function will return the result to the original object. So the target one-hot after this function will be changed. And the option here, 3 parameters. The first is means along columns. So along columns we will fill in the value, scatter in the value. And second option is from the target unsqueezed, because the target is a one-dimensional array. So we have to use the unsqueezed function for the second dimension. Then this target will be 2-dimensional tensor. Then we'll take out the value along the column. Then we'll set the value 1.0 to the position of this tensor. So it's finished. And because this target, we will show if target unsqueezed how it is going, right? So we use target unsqueezed for 1, which means second dimension, another dimension. So now target unsqueezed is this one. You can see now 2 brackets. But anyway, we will use target one-hot to machine learning for the target tensor. This is we just show the process for this part. So next operation is for the input data for this 11 columns tensor. So we calculate the mean along all the rows for each column. So we will set dimension 0 around rows and calculate all the mean value. So there are 11 mean value because there are 11 columns. And we calculate the variance also along the row for each column. Then we will normalize this data input by 0 mean and standard deviation 1. So we use the original data input minus the mean value for each column, then divided by the square root of the variance for each column. So now you can see the input data all has 0 mean and standard deviation 1. So this is the basic part of a tabular data input preprocessing. And of course, there are more works. For example, depends on the different discipline in the project, have to fill out columns or values or something like depending on the values or for the problem. So thanks for watching for this video.